Hello, today we're going to learn about combinations. Before we do that, let's review a little bit from yesterday. Given the letters for A, B, C, D, how many three-letter words can be made out of it? And by words, we're just saying three-letter permutations out of this. So A, B, C, C, B, A, all of that. Take a second, pause the video, and see how many you can get. All right, now if I erase, these are all the possible solutions. So there's 4 times 6, so there's 24 ways I can permutate 4 letters in 3 different positions. Now, how many combinations can you make if you don't care how the letters are arranged? Now, this is a little bit trickier question, so I'll erase all those again. Now, in a combination, ABC and ACB are the same because you use the same 3 letters. So all of these would count as one combination, where ABD would be different because there's a different letter in there. But every time there's many different ways I can permutate A, B, and D, actually 6 different ways. Now, so that you can see that there's going to be 4 different combinations out of the 24 permutations. Now, one way we can get this once we have our permutations is divided by how many ways we can permutate these 3 items. So another way we could say that is a combination of elements is a subset of those elements without regard to the order in which the elements are arranged. To find the number of combinations, we take the total number of permutations, which we learned the previous day, and divide that by the number of permutations of each one combination. So let's do some examples. So 4 choose 3. Well, what we could do is 4p3 and divide it by how many ways I can permutate 3 things, which would be 3 factorial. 4p3, I have 3 things. There's 4 ways I can choose the first, 3 ways I can choose the second, 2 ways I can choose the third, and divide that by 3 factorial, which is 3 times 2 times 1. So these all cancel out. 4 choose 3 will be 4. Now notice how this is written in the same way that we wrote permutations. Now it's NCR rather than NPR. 5 choose 2. The permutations would be, there'd be 2 things, 5 and now 4. And divided by how many ways you can permutate 2 things, 2 factorial, which is 2 times 1. Now this would be 20 divided by 2, so 5 choose 2 will equal 10. Now 10 choose 4. Alright, now this gets a little trickier. There's 4 spots, so it's 10 times 9 times 8 times 7. Now we divide it by how many ways we can permutate 4, so 4 times 3 times 2 times 1. Now to simplify it, 8 is divided by 8, which is 4 times 2, that'll cancel out. 9 divided by 3 will be 3. So 7 times 3 is 21, 21 times 10 is 210. Now another way that we can write this using factorials, we could say that this is 10 factorial on top divided by 6 factorial. That would give us 10 times 9 times 8 times 7. This is just like we did for permutations. Now we'd also have to divide out by 4 factorial there. So if I want to generalize this, what I can do is say n factorial over n minus r factorial times r factorial. Now we use this for situations like this. How many ways can you form a committee of 3 people from a group of 7? Now in this group of 7, it doesn't matter how you choose that committee of 3. If I do Tom first, and then John, and then Rich. If I choose Rich, John, and then Terry, or whatever T was, I forgot what I even named them, these would be considered the same combination. We can't count that twice. So this is the combination. 7 choose 3. So there's 7 times 6 times 5 divided by 3 times 2 times 1, which would be 35. All right, moving on. If a committee of 5 is selected at random, out of a group of 7 women and 4 men, how many ways can we form a group with exactly 3 women and 2 men? Now this is where combinations start to get tricky. The previous problem, I think this was pretty straightforward. We could ask more like that, but I think you'd get a little bored. So we're moving on to something a little bit more complex. So in this situation, we want to find the probability that the women is 3 and the men is going to be 2 out of our group of 5. Well, there's 7 women, and I want to choose 3 of them. And there's 4 men, and I want to choose 2 of them. So we multiply these two together. 7 choose 3 is 35. We already established that. 4 choose 2 is going to be 4 times 3 divided by 2. So that's going to be 6. So when I multiply that out, it's going to be 210. So there's 210 ways we can form a committee with 3 women and 2 men. So what would be the probability that you get 3 women and 2 men if we randomly select a group of 5 out of 7 women and 4 men? Well, we have 210 divided by all the possible ways we can form a group. There's 11 people, and we need to choose 5. So if I want to do 11 choose 5, that's going to be 11 times 10, 11 times 10 times 9 times 8 times 7, all divided by 5 factorial. 5 times 4 times 3 times 2 times 1. So 10 divided by 5 and 2 will cancel out. 3 divided by 9 will be 3. 8 divided by 4 will be 2. So this is 6. 6 times 11 is 66. 66 times 7. 42. And 13 plus 4 is 17. There's something I did wrong here, because this is 66 times 7. It's got to be, alright, try it again. 42, and then carry the 4. It's 42 again, plus 4 is 46. I think I added those. Pretty ridiculous. Alright, 210 over 462. Now, I don't know why I'm just not using my calculator. Let's just check to see if that was correct. 462, so 210 divided by 462 is 0.45 repeating. So that's the probability that you get a group of 3 women and 2 men. Now what's the probability that you get at least 4 women? So probability that women are greater than or equal to 4 in a group. Well, we have to figure out the probability that women equals 4 and add it to the probability that women will equal 5. So we want to figure out how many groups out of these. And we know the total possible groups is going to be 462. So we can put both of these over 462. Now the ways we can get 4 women would be 7 choose 4. And if we have 4 women, that means we have to have 1 man. So that's 4 choose 1. Now 7 choose 4 is 7 times 6 times 5 times 4. All divided by 4 factorial. 4 times 3 times 2 times 1. So this will cancel out to be 35. And 4 choose 1 will just be 4. So 35 times 4 will be, just to make sure, 140. Now, the probability that there's 5, now we have to find the number of ways we can choose 5 women, and that's 7 choose 5. And we're not choosing any men, so that's just what we have to deal with. So 7 choose 5 would be 5 times 6 times 5, 7 times 6 times 5 times 4 times 3. Divide that all by 5 factorial. 5 times 4 times 3 times 2 times 1. These will all cancel out. 6 divided by 2 will leave 3, so 7 times 3 is 21. So when I add these up, that's going to be 161 over 462. So 161 over 462 will get us 35, about 0.35. So there's about a 35% chance there'll be at least 4 women in the group. Now this one was how many ways, so how many ways would be 161? My next question would have been the probability. We answered it all together. Alright, given a hand of 5 cards out in a standard deck, if the cards are dealt face up, so order matters, how many 5 cards hands are possible? Well, there's 52 cards that could be on the first one, then 51, then 50, then 49, then 48. This would be a permutation. So multiply those together, and you'll have your answer. That's how many, so 52 times 51 times 50 times 49 times 48. So that's 311875200. Alright, a lot of hands. Now if they're face dealt down, now order doesn't matter. So the number of cards possible will be 52 choose 5. So that would be 52 times 51 times 50 times 49 times 48, all divided by 5 factorial, which is 5 times 4 times 3 times 2 times 1. Now I'll let you figure that out, because my calculator, I wish I had my other calculator at home, but I don't, so I'll let you figure that out. How many card hands can you have exactly 3 jacks? So let's just find the number of times we can have 3 jacks. Well, there are 4 jacks in a deck, and we want to pick 3 of them. If we pick those 3, then there's going to be 48 cards that are not jacks, and we want to choose 2 of them. So if I multiply those 2 numbers together, I'll find the number of ways that I can find exactly 3 jacks. Now what's the probability you get a hand with exactly 3 jacks? Well, we have to take our previous answer. 4 choose 3 times 48 choose 2, and divide that by 52 choose 5, the number of possible hands you can get. Now what's the probability you get 3 jacks and 2 aces? Alright, so first we need to find the number of ways you can get jacks. So that would be 4 choose 3. Number of ways you can get 2 aces, 4 choose 2, and then divide that number by 52 choose 5. And when you do so, you'll have that probability. Alright, here's the homework for tonight. Some of them are kind of tricky, so do as many as you can. Good luck.